This is Daniel Coosbury, and in this video we are going to finish looking at different ways to represent quantitative data. So we're going to look at a few different kinds of quantitative data graphs that are not histograms. So I made a separate video for histograms and things that are related to it. This video is just going to have a few extra ones that aren't quite histograms, but they're still used to represent numerical data. Let's go ahead and take a look at them. So we can start out with stem plots. So you might have seen a stem plot before. These are commonly called stem and leaf plots. That's a perfectly fine name. I feel like it's a little juvenile. I like to use a more technical term, which is a stem plot. And the way stem plots work is that you have data, and I have two different data sets here. So just let's think of one of these or one of these. And you're going to divide the parts of your data into what's called a leaf and what's called a stem. So if I look over here, I'm going to notice these are all two-digit numbers with a 1 decimal after the fact. So they all have this kind of thing in common. And I'm going to take the rightmost digit in each one of these numbers, and I'm going to make that my leaf. So I can recognize, like, by place value, this is my leaf. And then all the other digits to the left of that are going to be part of the stem. So these whole number parts are going to be called the stem. So this is the stem, and that is the leaf. And I made that decision just based on what the data looked like. So they all were two-digit numbers with 1 decimal place after. So I divided it that way. Now, you would use the same process with different kind of numbers. So these are all 4-digit numbers, no decimals. I would still do the same kind of thing. I would take the farthest digit to the right by place value. So these all need to be the ones place, and they would be called the leaves. And all the other digits to the left are going to be part of my stem. So that's kind of how you get started making this thing. Is you want all your data to you want to pick the rightmost digit in each data value. So it helps, like when you line up your numbers to add them or multiply them, you need the decimals lined up. You need the same place value over the same place value. You got to do the same thing when you make stem plots. That's kind of how this works. I'm going to show you a bigger data set right here. So we've got a table that represents the percentage of population age 65 or over, and the percentages are given. So these are percentages. They're given as like 14.1% or 8.1%. But we can note that the way the data is recorded, just like one of those last examples, each one of these data values has exactly 1 decimal place. So we'll make that 1 decimal place our leaf, and then everything to the left of the decimal will be part of the stem, whether it's 1 digit like 8 or 2 digits like 14. And we can take this data and we can make a stem plot using this method. So you would take numbers like, for instance, I would take 8.1, and on my stem plot, the stem part will be the 8. The 1, the 0.1 will end up over here. So all the decimal values are ending up over here. So the same, I have a value of 9.0. The 9 is my stem, and the decimal 0 is my leaf. Even though it's a 0, I'm still going to put it on here. And then you just keep doing that. So for like 11.5, notice I have an 11, and then I have a 5 here, and then another 5. That's because there's an 11.5 right here, and there's also another 11.5 right here. So it's counted twice because there's 2 of them. So I put these 2 5s mean there's one 11.5, there's also another 11.5. So we can read stem plots. They're not too hard to read. You get a little practice with them, and they're not too difficult. So for instance, there's a 12.0, there's a 12.4, 12.7, 12.6, there's another 12.6, another 12.4, and so on. So that's how you would go into making this. And it's worth noting that a stem plot's not really complete. It's not really proper until you order your data. So the suggestion here is make it first and then order it from least to greatest. So now you can see where the repeated values are. You see the 4s and the 7s. So there's 4 different data values that are all 12.4 in the map, in the last table. So stem plots are nice because they show you things like that. This isn't really as good as a histogram as far as looking at the shape of the data, but we can still see kind of an overall, we can still see kind of an overall shape if you look kind of like that. So it's not perfectly because those numbers mean different things, but if you wanted to group them by tens, you do have kind of a shape that shows up with stem plots. So they're not too hard to make. They're kind of nice to look at. And related to that, we have back-to-back stem plots. So this is possible when you have two different data sets and you're on the same scale or similar ranges of numbers. So this wouldn't work. We wouldn't be able to do this, for instance, with these two data sets because this is in the tens place, this is in the thousands place, and it just wouldn't be a good idea. But here's some class averages. So these are averages from an English class and averages from a history class. They're on the same scale, like they're ranging, they're all double digits up to 100. And so what we can do is we can put the tens place here. So the leaves are going to be the ones place. It's always going to be the furthest digit to the right. The leaves are the one place. This is the tens place. And then we just put all the English classes on one side, all the history classes on the other. So that kind of looks nice. You can see there's a 45 in English. There's a 92 in history. Notice how these are going up, going from right to left. And putting them side by side can be useful. For instance, if we're interested kind of in the shape, we can say, oh, well, that's kind of normal. It's kind of symmetric. That's kind of symmetric. But an important thing to notice is that there's a lot more 70s here. There's a lot more 80s here. By and large, the history grades seem to be better than the English grades. And maybe you couldn't tell that as easy from here as you could from putting it on a stem plot or back-to-back stem plot. Similarly, we can make dot plots. So this is a very rudimentary kind of plot. This is useful when you have small discrete data sets. So it's helpful when you can just list out what the numbers are. When we have continuous data, we want to make a histogram or something like it. Like we got to group it. We got to make classes because it's continuous. But when it's discrete, like 0, 1, 2, 3, 4, 5, we can just count the number of ones, count the number of twos, and so on. So like in this, you got discrete data. They're all the counting numbers, and you can see there's like 1, 2, 3, 4. You know, there's 5. There's a 6, 0. And all the dot plot does is it goes by each number and it counts the number of times it shows up. So this means there's 6 zeros, there's 2 ones, and then you can count that, see how many twos there are. That's a dot plot. They're really nice. You can also see a sense of the shape of a data set using a dot plot. So you can do something like that. You can see that's kind of skewed to the right a little bit using the dot plot. Notice this dot plot doesn't necessarily have to have all the things labeled. So we know even though there's 0 and 2 here, we know that's 1 and that's 3 and so on. Dot plots are nice. They're not hard to make. They're not incredibly common, but if you do have a small discrete data set, it's kind of a nice thing to produce. Most people know how to read it. Another thing you will find useful, especially if you're in the business field or if you have research data for a lot of years or a lot of months, is something we call a time series plot. So we often find ourselves taking measurements of the exact same outcome at different points in time. So we're measuring the same thing over and over again. We're just doing it every month or every year. When you do that, you end up with what's called time series data. So this is an example of time series data, where in the first column you have the years it was taken, and in the right column you have whatever thing you're measuring. In this case, it's the Dow Jones Industrial Average at the end of the year. So this would be the very end of the year. So for each year, we take exactly one measurement, and then we put it on a graph like this, where the years are on the x-axis and the measurements are on the y-axis. So that's important to get that right. And then with time series, it's in an obvious order. So this is definitely like you go from 2003 to 2004 and so on. Usually you connect the dots with time series. You can't always connect the dots on plots like this, but when you're dealing with time, it's in order. And so you can do that. There won't be any sort of weird overlaps or strange shapes. So this is a time series. It's really useful. I'll show you how to plot one of these in just a sec on the TI 83, 84. But before I do, I wanted to show you a scatter plot real quick. So this is very similar to a time series. So a lot of times when you're doing a study where you're comparing two variables or you're seeing if they have some kind of a relationship, what you'll do is you'll take two measurements from the same individual, and then you end up with what's called a paired data set. So for instance, I'm looking at the size of houses that are on the market compared to how much money they sold for in $1,000. So for each house, I'm gonna take a measurement of its size, and I'm gonna take a measurement of its selling price. And so you see these numbers go together because they're from the same house. That's why we call it a paired data set. So we assume each one of these rows is a different house or a different individual. And when you have a paired data set, then you also have, you can easily make ordered pairs, which is something we learned from algebra. So an ordered pair is just a list of two numbers, but they're in order. So the X comes first, the Y. So here's a plot of all those ordered pairs from this table. So you can see this is the first value. This goes up to, it goes to the right to 25, 21, and then it goes up to 400. And you can plot all of those. And then you can see like trends in the data. So for instance, you can kind of see as a whole, this data set is going up. We might look at a little bit more at this later. But as a whole, it goes up, and you can see it from this kind of thing. It's called a scatter plot. So when you have a lot of data, even 10 values is good. When you have like hundreds and hundreds of data points, scatter plots become really useful because sometimes you see this big blob that tells you nothing. Sometimes you see like a linear trend where it's going up or it's going down, and it's also useful. So at this point, I want to show you how to make a scatter plot on the TI calculator. So I'm going to pull mine up and show you. I haven't done much with the TI calculator yet. We're finally getting into working with numbers. I want to put it over here. Well, I guess it's going here. Okay, so with the TI calculator, to do anything with data, the first thing you want to do is hit this stat button. And once you do, you see an edit button. So I'm going to hit stat, and then I'm going to click enter to hit edit. And I've got into my list catalog. So you can see this list catalog has rooms for a lot of lists, and you can fill them up with numbers. This is where we're going to put in data sets. And I've already taken the liberty of adding in the house cost column and the housing price column. And I did it so that the data is paired. And I want to plot this data set. So I've got the housing square foot in L1, and I got the the housing price in L2. So to plot it, this magic button here, the Y equals, is how we plot everything in a graphing calculator. To do this, plot the data, you want to hit second Y equals first. So you want to get this little stat plot catalog, the blue one. So hit second Y equals, and now you've got a bunch of different plots. I'm going to go ahead and hit enter to get the first one. So I'm in plot 1 now. And all I want to do is I want to make sure that plot 1 is turned on. So you can turn it off. You can turn it on by hitting enter. I want to make sure it's turned on so it plots this data. And then I want to tell it what plot 1 is. So I'm also going to select this little button that has a bunch of dots on it. That's my scatter plot. See how it looks like this? So the little dots is a scatter plot. If you were doing a time series, you would plot this the exact same way, except I would click the line button instead. So if I had time series data in L1, and or if I had the years in L1 and the Dow Jones in L2, I would click this, and it would plot time series the exact same way. I'm just going to do a scatter plot. And then I'm going to go down and make sure my X list is L1, so that's my square foot, and my Y list is L2, that's the selling price. And then this just shows you, this is just what the dots are going to look like. You can make plus signs or tiny dots. I'm going to make big dots like this. So once you've done this, the plot 1 is on. This box should be shaded. And then you need to hit the zoom button. Oh, no, maybe get out of this first. Let's get out of this. Second quit. Okay, so we've done that. Let's hit the zoom button. And I'm going to go all the way down until I see zoom stat. So anytime we want to do a scatter plot, let's go find zoom stat and hit enter. And there's my scatter plot. Looks exactly the same. So if you missed some of that, go back and look early in this video. But plotting data is not a very hard thing to do. You just want to make sure when you go to second Y equals, your plot is set up right, and then hit zoom stat, and it'll show you all your data points. So make sure the plot's turned on and it has the right lists. My lists were L1 and L2, but if you put one in L3 or L4, you can change those things. It's not too difficult. But anyway, that's how you'd plot a time series graph or a scatter plot in the TI. And that is it for plotting data.